Всем привет, с вами Хвостович Александр, ведущий проекта «Америка для успешных». Мы сейчас в очереди в Hackers Dojo. Мы сюда пришли посмотреть на всякие разные виртуальные продукты, виртуальной реальности. И горячая новость — это, конечно же, Oculus Rift. То, что он вчера фактически был куплен Фейсбуком, здесь сейчас все это обсуждают. Мы вам поснимаем вокруг, что происходит, разные прототипы всяких виртуальных девайсов. Вот. Ну и также я познакомлю людей с Oculus Rift и поближе. Вот. И я думаю, что вам понравится. Так, ну начинается все прилично, с еды. То есть нас здесь кормят, можно подойти, взять себе сэндвич, покушать.
Probably turkey. Is my guess.
It looks like it is. Там уже начинается шумиха, люди потихонечку собираются. Вот. Ну, как я уже сказал, что почти все говорят об этом Oculus Rift и о покупке его Фейсбуком. Но я вам, наверное, немножечко про саму компанию расскажу, чтобы вам было понятно, что это такое и куда это вообще все движется. Значит, Oculus Rift был основан в 2012 году. Вот, и они начали сбор средств через Kickstarter. Здесь есть такая платформа, где человек может рассказать о своем проекте, показать какие-то прототипы и скидывать, дать свою идею людям, и люди начнут сбрасывать деньги. Вот, в 2013 году они, в принципе, закончили сбор средств, и уже был первый продукт, который начал где-то с лета 2013 года доступен. Он был доступен исключительно разработчикам, как и сейчас, в принципе, да. Вот. И из себя это представляет такой монитор, который я его потом сниму вам, который очки такие с мониторами, которые надеваются вам на голову, и вы можете видеть как виртуальная реальность, то есть телевизор прямо перед вашими глазами, управлять разными предметами, то есть в игре, то есть руками. Что касается технических спецификаций этого устройства, то на текущий момент они таковы. Значит, разрешение, которое поддерживает Oculus Rift, 960 на 1080 пикселей. Значит, в релизном образце, как они обещают, когда они выпустятся, он будет Full HD. Очки воспроизводят стереоскопическую картинку в пределах 90 градусов по вертикали и 110 по горизонтали. То есть вы можете смотреть по сторонам, вверх-вниз, вам будет все видно, и картинка перед вами игрового мира тоже будет меняться. Значит, в качестве портов можно использовать DVI или HDMI. Частота опроса картинки составляет 1000 Гц. Для отслеживания движения вашей головы используются сенсоры, как гироскоп, акселерометр, датчик магнитного поля. Значит, что касается программной поддержки, то тут тоже все в порядке. На текущий момент полностью поддерживаются все настольные операционные семейства Windows, Linux, MacBook, Steam. А дальше планируется поддержка на Android и iOS. Значит, что касается игровых движков, поддерживаются CryEngine, UDK, Unity Engine Source, Unreal Engine 3 и 4. Это достаточно впечатлительный список, и, как очевидно, он будет только пополняться. Уже есть игрушки, я вам дам список ссылок внизу в описании к этому видео, да, которые вы можете посмотреть и перейти, посмотреть, как люди играют в разные игры, как это выглядит со стороны, реакцию стариков, когда их надевают. Вообще очень классная штука. Вот. Но вот в данный момент их поддерживаешь. Half-Life 2, Haken, Mirror Edge, War Thunder, Skyrim. Вот. Достаточно известные имена. И как мне кажется, что больше всего это, конечно, очки подходят для игр FPS, First Person Shooter жанра. И чтобы комфортно поиграть, вам потребуется достаточно мощная видеокарта и хорошая конфигурация компьютера. В принципе, официальных системных требований еще объявлено не было, но я думаю, чтобы смотреть комфортно в 1800 пикселей в стереоскопическом 3D, вам потребуется как минимум одна карточка уровня GTX 780. Но лучше, конечно, если их будет 2 или 3. Значит, процессор Core i7, начиная с Sandy Bridge, и как минимум 8 гигов оперативки. ну, как бы для того, чтобы уменьшить задержку между поворотами головы и обновление картинки, нужно очень много терафлопс. Вот. Касательно перспективности этого проекта, ну, как бы, это, мне кажется, это одна из революций, которая грядет, когда появились мобильные устройства, потом появились iPad, iPhone, то есть, ну, как бы вот эта мобильная революция, да, которая, когда телефоны стали как компьютеры, это, скажем так, был первый шаг. Я думаю, что Oculus Rift это второй шаг, когда мы сможем при помощи виртуальной реальности там учиться, играть в игры, двигаться. Просто они могут быть еще очень активными. И я думаю, что всем стоит заценить видео, ну, как бы, которое будет внизу в описании, чтобы вы могли иметь представление, что это такое, какие перспективы это открывает. Как для общения, так для обучения и, ну, и безусловно, для игр. И еще одна деталь, что даже сам Джон Кармак, то есть отец Кваки и Дума, третья часть Дума уже поддерживается очками, он ушел из стен родной ID Software для того, чтобы поработать над этим проектом. То есть это очень большая штука. И сейчас, то, что я уже говорил, самая обсуждаемая новость, что Facebook купил ее за 2 миллиарда, и почему-то, ну, как бы все IT-сообщество считает, что проект можно похоронить. Что Facebook непонятно, что с ним сделает, и не будет ни разработок новых, ни улучшения, ни официального релиза, и вообще непонятно, зачем соцсети, да, этот продукт. Но мне кажется, что это все-таки a good thing, то есть это хорошая вещь, потому что у них есть средства, которые они могут вложить, и они будут стимулировать развитие проекта, безусловно, а также будут стимулировать конкурентов. Плюс они, как бы, ну, неизвестно, сколько это правда, но, как заявил Цукерберг, что они не будут мешать развитию проекта, просто будут финансироваться проект, как бы, как занимался игрушками на данном этапе, он так ими и будет заниматься. Вот, это для тех, кто вообще не знает, что такое Oculus Rift, и примерно вам рассказать, да, об этом продукте, куда он движется. А сейчас мы пойдем вообще поснимаем на этом этапе, какие есть разные виртуальные реальности, продукты виртуальной реальности.
Scott, he moved a little closer, but
You want him closer or further?
no, he moved closer, so
Oh, okay. So you don't want to scooch here, so you're going to let it here, and then maybe back a little bit. I kind of hope you put this on your head. You can kind of guide that over your eyes. Got it? Rotate your hands. The left joystick will make you walk. The right one will rotate your character. And the triggers will close your hands to pick up objects. So you can walk forward and grab that gun on the table. Just rotate your... So, back up your chair a little bit more, actually. Okay, there you go. And then just trigger to shoot.
Which one?
Right trigger.
Again?
Yep.
Hello everyone, this is full house today. Level sound good? Alright. Alright, so I guess we have a lot of people here, a lot of
To get you out of there, it looks like we're getting started.
Obviously no slides. We at High Fidelity are just getting ready to start our alpha program. We've got a bunch of people, probably some people in here that are on that list. We've let just a handful of people log in the last few weeks to sort of ensure that for what we've got working right now, things are running. And rather than say much about what our plan is, I did that last time I was here, let me just show you a little bit of what we've got going on in the alpha program live right now. So, wait, one more plug, just one plug. Okay, wait a minute. Here come my hands. Just wait, hands are waking up, hands are waking up. Oh, there they are. Hands are waking up. My hands are calibrated. They're in front of me. So look, fundamentally, we believe, high fidelity, I believe that sensors, not just things like the Oculus, but more specifically, devices, as you're seeing here, that are able to capture my movement, my facial expressions, my eye movement, looking at you. Sensors like these are about to revolutionize what we're doing in virtual reality. I think for a lot of reasons, and I'm going to show you some of these, being able to use these devices to make the process of getting into a virtual world and the actual qualitative experience of being there fundamentally different is going to take us from the million people that are using Second Life today to a billion people using something that we're all going to build together. So let me just show you a couple of crazy pieces of that. So when I say qualitatively different, the first thing is the experience of talking to somebody else is going to be completely different. And here is a somebody else. Hi, Emily.
Hey there, Philip. How are you?
We have a little more. Good to see you. Hello. So Emily, welcome. Welcome to SVVR.
Thank you.
Emily works at High Fidelity for us and has spent, well, her first time in virtual reality in the last year or so.
Yeah, pretty much.
And among other things, Emily has spent every Friday with the rest of us in our company meetings, which are roundtables where we are doing exactly this, where I'm looking into the screen or into Emily's eyes as I am here, and she's talking to us. So I mean, one thing I was going to say, well, Emily, what does it feel like? What's different between, what's it like to be an avatar now that you've done it so much?
I actually find it really enjoyable. I really like to watch. Really expressive. I definitely miss the facial expression if the camera's not on, and it's a totally different experience. I just love it.
So, in terms of showing you this, well, what's a good moment that you've seen at a company meeting? What comes into your mind?
I just love the alpha meetups. It's the last couple of meetups that we've had just do show and tell, and one of the things that comes to mind actually is the xylophone. When you first brought that out and you showed us how to make different noises on different colored voxels, it was just mind blowing.
I can actually show some of that today. That was one of the first things we did with with our hands, basically. Now talk, whisper into my ear, Emily. Can you say something?
Can you hear me on this side?
A little louder. We don't have it that loud. Maybe
Can
okay.
you hear me on this side?
So one of the things that's crazy about this is the whole world of High Fidelity is completely spatial.
We're going to show you a crazy
Well,
We're going to show you.
we're going to show you a crazy demo of that in a second. We had to punch a hole in the Dojo network here, or change our software a little to run on it, so it may come in and out a little bit. But basically, first of all, the me that you're hearing and the Emily that you're hearing are happening with a latency of about 100 milliseconds. Your cell phone has a latency of 500. A voice over IP system is 700, 900. So Emily and I can cut each other off. She can nod. We can look at each other in ways, because of that 100 milliseconds, that you just can't do with anything else. So this, we think, is, along with the sensory devices, is totally revolutionary in terms of capabilities. So let's see, that's great. It's just totally intoxicating to like watch yourself and watch somebody else when you're talking to them. You've also seen that when I move in front of the screen, I can look around Emily, not with the Oculus, but just by doing that in front of the screen. And that was the trick I was showing you with her talking into my ear. You can't kind of tell without a headphone on, but basically, when I'm moving back and forth in front of my team and you're listening to each other, you're hearing the audio change just like it does in the real world. Audio is a huge, huge part of virtual reality. It's not, nobody's working on it enough. It's one of the things that I always put out there whenever I'm talking to people about it. So we started with audio, with mixing in all this audio together. And I want to show you, well, let me show you a couple other things, just in terms of capabilities. So thank you, Emily. I'll make a mess of things a little bit. So the feeling of talking to Emily is one thing, but what about building in the virtual world? Well, the other thing that's different, right, is you can build in Second Life by clicking on things and dragging and turning. You can do the same thing in AutoCAD. But if I hit the keys here, right, turn on my little building tool here, right? You know, drawing something like, you can go around Emily there. Oh, that's crazy. You know, I mean, I'm doing this with, I'm building voxels there, solids that, you know, she can see the same as I can. Basically, in the world, in real time, you know, I can click down there and switch the colors. Now, one of the things that you'll see when you jump into our output is everything here, this tool that I'm showing you, the way that it maps the motions of my hands in the Hydra to stuff in the world, is done completely in JavaScript. So this is literally a JavaScript file called edit voxels that has support in it for the Hydra controllers, and they're being drawn in. That little UI down at the bottom of the screen. Emily, you can click on something there if you want, like delete some of the voxels. Of course, Emily can edit this thing at the same time as I do. I can do it by clicking. Just keep sort of building things here myself. Let's see. Another thing about our system is blocks. So it's a bit like what you're seeing right now is a bit like Minecraft, but imagine a Minecraft where you can make the blocks smaller. This is where the thing we're missing with controllers is not having to hold. You know, and then start digging. But the fundamental way our system is designed is around an octree, a voxel system, in which those blocks can be infinitely subdivided. They can be as big as the whole world itself and as small as an atom. And so that's another part of our system. Now there's a lot of other things you can do with JavaScript and with these controllers. And you know, if you look at Second Life, Carl was mentioning the big economy that it has of people buying and selling things to each other. Imagine what that's going to be like when we can build things that at 60 frames per second work as well as things like this. So for example, let's see, I'm going to load some JavaScript that we've built. And we're hoping with help of our alpha users, you're going to soon see a big catalog of lots and lots more objects that are built this way. So, now with this, I can throw balls at Emily. It was well protected. You hear it? Then, but of course, better watch out, Emily, because I can stop the toy ball script and just go straight for the guns. Weren't you all thinking that? Where's the gun? Find the gun. There's the gun. So now, sorry, Emily. And what's better is the gun blows holes in the voxels, so we get through to Emily there. So, really, really powerful system where you can use JavaScript and objects. We can also do objects that are models as well, so fully rendered 3D. Obviously, Emily there is not made of voxels, she's made of triangles. Again, before going back to that latency thing, I've never done this. This is the first time we've ever done this. You're hearing me bouncing off our servers. So you're hearing me about 90 milliseconds later. We've done tests on this. What you'll notice, right, is at least for you guys, turns out it's a little harder for me to do this. I'm kind of trained in it. Look at my lips and listen. This is exactly what it's going to feel like when you're talking to somebody in the virtual world. Because there's a feature we have called loopback where I'm playing this audio through exactly as Emily's hearing it. And what you're going to experience with a little luck here is about 50 different little machines, individual processes, that are simulating the space, but each one of these, as I'm going to show you, is, oops, boy, I'm shooting somebody. Hopefully that won't happen when I go inside the club here. So listen. You'll start hearing, I'm not even close enough yet. Of course, all the sound is spatialized. So that little guy up there playing the music is one little borrowed machine. How cool is this? Now let me explain what's happening down there. So There's 40 little avatars down there, and each one is running on a separate device. It's actually running on a separate thread in one of our servers right now, but we've done this on our cell phones. And by the way, a dancing avatar is a perfect thing to do with a cell phone in terms of bandwidth and computation capability. But here's what's a trip. Watch them dancing. You'll see they're responding to my voice, which I'm going to get closer to show you. It's the funnest thing. Each one of them is receiving a full, about 700 kilobit audio stream. Same stream we're listening to. And the latency in the system is so low, we've programmed them to kind of be a little resonator that just samples the music rather than playing it out on any speakers and moves around according to that. They're also moving their joints. The joints are fully articulated, so you can move, you can build any skeleton, load it into here, and then move it any way that you want. And if I get close to them, you can see that mixed audio really works. So the closest ones to me actually jump up in the air like that, while the rest of them are listening to the DJ music that they can hear. So that's pretty crazy. I mean, I don't know. Even as the creator of Second Life, when we got that working, we got this working yesterday with all the movement and everything. I was just like, this is crazy great. So that's about where we are in Alpha. We're just starting. We're inviting people that are hopefully have a bit more of a development sensibility or content creation capabilities to come in with us in a relatively small group and start building experiences like this and just see how far we can go with it. We don't think there are a lot of limits. The network latencies are low enough to allow this presence, as Sebastian very aptly said, this actual sense of connection and immersion with somebody. The machines are so fast, we don't even know what to do with them to slow them down.
What was it in the end?
So cool.
You get to see it.